Could I have your attention over here for a moment, please? Now, you see this notice? Now, you all know that it's breaking regulations to expose live metal, but craftsmen still keep taking risks. Stop the risks and stop the accidents. Good afternoon, gentlemen. Yesterday, you remember, we were talking about people taking risks, and we also discussed certain aspects of safety. We have with us this afternoon the area safety engineer, who's going to talk to you about the importance of safety. And I'd like now to hand over to him.
Thank you. Good afternoon. My prime concern in coming to talk to you engineering trainees is safety on the job. Now, you don't need me to tell you that your job carries very grave responsibilities. But it is failure in two of the most elementary of these responsibilities, that is isolate and check, that is resulting in our present level of accident and incident rate on the ground. Now, you will all have seen at some time this book. I'd like to read just a short paragraph from it. It is the responsibility of every electrician carrying out work on electrical apparatus to satisfy himself that the apparatus is in fact dead before attempting to work on it. Now, you'll notice that the rule doesn't say that the electrician must personally isolate. This can be done by any other authorized person who can be instructed to isolate, to lock off, and hang on a warning notice. But what the rule does say is that the electrician must satisfy himself that the apparatus is isolated. The man in charge of the job is responsible for the correct isolation procedure being carried out. Now, I've no doubt you've heard that dozens of times, so why am I repeating it? It's simply this, that these two safety regulations are not always carried out, and because they're not always carried out, we continue to have accidents.
Talking of accidents, would you care to say a few words about the illegal use of rectifiers?
Yes, sir.
Have you still got that rectifier, Bob?
Yes.
May I have it, please?
Thank you.
Thank you.
Thank you. These rectifier hookups are an example of a bad practice which is a direct cause of accidents. These wires have only to slip a fraction, and it can result in you and possibly many others underground becoming hospital cases. Now, you should always use the proper test equipment and never, ever take a calculated risk with things like this. Now, let's examine some of these calculated risks. We have a pretty wide collection in our reports on electrical accidents, and I brought along some photographs to show you of the consequences. This accident occurred only last month. We'll call him Jack. He's 20 years old and has just finished his apprenticeship. He was given the simple job of installing an extension cable behind a set of gate end boxes in a heading.
Well, you reckon I start them first? Well, it would all look, really.
Oh, we just put him in line for a snack at the championship.
Hey, up, Jack. I've got to start with you tonight. Move the cable up.
Okay, sir.
You going out on the first paddy then, Bill?
Well, if you're taking the power, I shan't be able to run the belt on that just as well.
Will you put the section switch out for me on your way out then?
Yes. But which switch is it?
Oh, you can't miss it. It's the first one at the end of the gate.
Okay. Cheerio.
Cheerio, Jack.
The first switch. Is that it first?
Well, that's the first switch coming into the end of the gate, and that's the switch he said.
Oh, well, you're the gaffer.
Oh, well, that's it. That's okay, Cyril. I suppose Bill should have put the section switch out by now. Should have done, I think. I suppose I'd just better check the breakers to make sure. Here's a test plug, Jack. Oh, I've been let down with those things before, Cyril. I'll use this. Don't be a bloody fool, man. There've been accidents with those bloody things before. You fool, Jack. I told you not to use that thing.
He spent many weeks in hospital. You see his hand before treatment. He lost a thumb. They did a marvellous skin graft on his face, but I'm afraid he lost an eye.
Can we smoke, sir?
Yes, you may.
Now, it isn't only rectifiers that cause the accidents that should not have happened. We have a lot of our electrical machinery that is fitted with safety mechanisms which prevent any person doing maintenance or doing tests on any live circuit.
That's what he thinks.
And of course, the clever dicks will know how to beat a safety interlock that is put there for your protection. Just in case you think I'm making up horror stories just to scare you, I'd like one of you to come out and read from one of these reports. Now, who's it going to be? Come on, you'll do. Never mind the dates and places, just start from there.
I got a call on the phone saying there was trouble with the boarding machine. It wouldn't switch off, and they had to switch it on and off from the transformer panel. And would I hurry up and have another look at it? This was the third time I'd been called to fix this drilling machine, and I was getting fed up with it.
I've nothing but bloody trouble for 3 days.
Seems to be all right.
It must be the box.
Go and have a look at it for you. Have a look.
I thought I'd check the gate end box, so I switched off the isolator and opened the door. And to save time, I fiddled the interlock to bring the isolator back to the on position, so as to get the power back into the box with the door open. I could now see what relays were working and what was not working, instead of spending a lot of time making separate tests. I could see the pilot relay was not working. It was bent in and not breaking contact. I was nailing on some loose shingle, and my toe was wedged against the tub rail.
Bloody hell! First! Hello, what's up? Come here, quick! Knock the power off! He's not breathing!
And that's how they found him, with his meter and test plug near at hand. But obviously, he had not used them.
Thank you very much. That was very good. So you see what happened. He wanted to see all the relays working without using the test plug and meter. So he defeated the interlock. The result, he lost a hand. He also got some pretty bad burns to the leg and foot. Now, must electricians get burns like these before they get the safety message? It's not that your job is dangerous, provided you keep to the regulations and isolate and check. It's far safer than driving a bus. The trouble is, someone's always in a hurry, trying to cut corners. Now just look at those burns and ask yourself, is it worth it? There's bound to come a time when you feel inclined to take a calculated risk. With new equipment, for instance. If you come up against a piece of new equipment that has you baffled, don't be too proud to ask for help. Ask the man who set you on the job. That's what he's there for. The other thing you must learn to do is to keep calm when a power failure causes a production holdup. That's when the spotlight is on you and the pressure starts to mount. That reminds me of a case I have here.
Hello, Bob.
Hello.
The shearer's standing. The isolator's jammed again. Can't get it on.
I better come and have a look.
Oh, well, how long are you going to be?
I'll be down soon.
Oh, well, get your finger out. Hurry up.
It'll be about 50,000 now for the Rams, you know.
And I'll tell you what, they'll want 50,000 players, no more than they'll do.
Here it is at last.
Oh.
Where the bloody hell are you been? Been waiting half an hour.
I'll go down.
Come on, Bob, can't you stick a bit of wood in this relay and let's get going?
I didn't make the motor break down,
I know, it's your bloody tackle though, ain't it?
This bloody thing's stuck again. Over a mile to the section switch. I'll have to chance it. Damn it. That would happen. This is going to hold things up even longer.
And he not only knocks out all production for the rest of the shift, but he finishes up with a hand like an underdone steak. Another important problem arises in the issuing of instructions to work on electrical apparatus. Now, I've had a very serious accident which occurred because instructions given over the telephone were misunderstood. Now, take a look at this diagram. Here is the substation transformer at the pit bottom. Leading from it is a .06 cable supplying number 5 district. And at number 2 substation is another .06 cable feeding 3.3 kV to this oil circuit breaker at number 1 transfer point. The oil circuit breaker connects to this 150 kVA transformer, which in turn supplies 550 volts to this bank of 4 gate end boxes. The electricians had orders to change the oil in the oil circuit breaker at number 1 transfer point, to shift these gate end boxes into a roadway nearby, and to install a new 200 kVA transformer to feed them with. The 3 electricians went off to do the job. It so happened that there was some very urgent work going on in by from number 1 transfer point. This work was too urgent to be interrupted. So until number 2 substation was free, they carried on by isolating the oil circuit breaker, so that they could then disconnect all the 550 volt equipment and shift it on to the new site. By the time they had done all this, number 2 substation was free for them to isolate and to reconnect the 3.3 kV line to the new 200 kV transformer. Alf is the charge hand.
Will you phone up Fred Brown at number 2 substation and tell him we want a word with him, please?
Okay, Al. Hello, Tim?
Yes?
Is Fred Brown there?
No, he's just gone. Start pit bottom.
Hello, Fred?
Hello, Bill.
Oh, Fred, hang on a minute. Alf wants to have a word with you. Alf? Fred's on the phone now.
Okay, Bill, come and give Charlie on, will you? Hello, Fred.
Hello, Al.
Will you isolate the 06 feed up or down here, please?
The 06? Right, I'll do that right away.
And when you've done it, ring me back just to make sure.
Yes, I'll ring back.
You see how the mistake took place? Alf thought he was talking to Fred Brown at number 2 substation. But Brown was near the pit bottom substation. And that is where he went to switch off the .06 feeder. Brown located the switch, switched it off, and locked off. Fred Brown then phones up, but this time Charlie, the third man of the group, is near the phone, and he answers it.
Hello.
Is that you, Charlie?
Yes?
Oh, tell Alf the 06 is dead. I've put my danger notice on and padlocked off.
Right, I'll tell him.
Alf, Fred says he's isolated and locked off.
Okay. Come on, Bill, let's go and get some cable while Charlie pulls the pins out.
Alf! Alf!
Hello, what's wrong?
Come here, quick! Charlie's hurt!
Pull that alone, get that power switched on.
They tried for an hour and a half to revive Charlie, but it was no good. Fortunately, lethal accidents like these are very rare. Thank goodness. So you can see how essential it is for instructions to be clear and precise. But what about the other men in the pit? Do you include them in your calculated risk? Is it possible to exclude them when you take a calculated risk underground? Here's a case in point, my last one.
Hello, Alan. Ray speaking.
Hello, Ray.
The shearer's stopped.
Trying to stop switch.
I've tried that. It just won't go.
I better come down.
Okay, be as quick as you can then.
Hello, Arthur.
Hello, Ted.
The manager wants to know how long the electricians are going to be down there.
Hang on a minute. I'll go and ask them.
on, you Dave. Hurry. Give us a hand here.
Most of them were men with families. There was no one alive who could tell what set off the explosion, but the inspector found the power had been on at the time of the explosion. All the electrical and signalling equipment were found to be in good working order, except the gate end switch that supplied power to the motor. The bolted plug of the control cable had been withdrawn from the back of the switch, leaving the pins exposed. Inside the switch, the earth leakage relay and the proving relay had both been removed and were found lying on the floor. And in the open sockets of both these relays, someone had put in pieces of wire so as to remake the circuits. And the stop switch contact had also been bridged with a piece of VIR. Immediately below the switch, the inspector found a damaged rectifier, like this.
Who do that?
Yes?
The electrician may have got burnt, but why did it blow up the whole district?
Indeed, why? This particular face was regarded as virtually gas-free, based on regular samples taken during production. But a gas-free face today does not necessarily mean that tomorrow it will be gas-free. Where there is coal, there can always be methane. Now let me show you what happened. This is a film record of a test carried out at our research centre. That big cylinder you can see on the right is filled with methane. The cover of the gate end box is unbolted. It is all enclosed in the airtight tank. An 8% mixture of methane and air is injected into the tank. Now see what happens when the contactor is operated. When you take a calculated risk with your own life and limb, you're putting the whole pit at risk, not just yourself. Perhaps the electrician had taken the same risk before, perhaps quite often, and got away with it. But on this particular day, and I quote from the report, fire damp was ignited by an electric arc within the gate end switch, which the electrician was testing with the flame-proof door open. If only the electrician had isolated and tested properly on that particular day, when there was an unusual build-up of gas. Instead, the whole district blown up. 39 men lost their lives. Hundreds of thousands of pounds worth of damage. 7,000 tons of coal a week lost. And a year afterwards, the whole pit was closed down. Finished. You might get away with it once, twice, but one slip, and you can never put the clock back.